We are here in Nederland, Colorado, and we just had some epic shakes. Woo!
Ready?
Strip mall, mountains, huzzah! We are now here at Window Rock, i.e. big hole in rock. What do you think, Whisker? Is it safe to go out there?
It's windy.
Yeah, it is.
I've seen bigger.
Have you? I'm not sure where. It's a small room, but it's in an 1800s location with a really neat view.
Just saved you a lot of mystery.
Mystery? Look at that. That's cool. There's an Italian bistro. And a little... Look at that tiny... It's like a pretend gas station. Pine Country restaurant. Very cute.
Aha!
Golden Gate Bridge. Slower traffic, keep right? Okay, no problem. We saw an HOV lane go into rock just before the Golden Gate Bridge. I felt a little nervous after that.
It'll probably be our last trip to San Francisco in a long time to come.
Yep. I think they're taking down the Bay Bridge. Actually,
they already changed it.
Because they built a new one, right?
Yeah. We're not going over that one today.
No.
Just this one.
Golden Gate.
Yeah. You guys want to go to the ocean?
Ocean.
There's Pacific. There's San Francisco Bay. San Francisco back there.
Very nice.
Alright. Time for us to go pay a toll.
Yep.
And the one pancake?
We are at the Internet Archive.
Archive.org.
Archive.org. And this is like an old, I don't know, Masonic temple or Christian Science, something or other. So I think during noon times they have, what, like get-togethers?
Lunch and tour, yeah, Fridays,
Yeah.
I think.
So we're gonna go and do that.
See if they let us in. Last time I see her chasing it back.
Yeah, so in the 60s they didn't show him doing all all the like cocaine and stuff with the Atari guys in the 80s.
Oh, yeah.
They left out that part.
Who wasn't doing
Segment of the original internet.
Oh yeah, me neither. But I was only 5. Segment of the original internet.
Well, when you need a detox.
Not creepy at all.
So, we thought we'd flatten the floor and make it into a library, but exactly what a library is now, it starts to become a little bit hard to know. So we thought, okay, well, let's adapt to it slowly and sort of, you know, do no harm. So these are that's about 2.5 petabytes of the primary copy of the Internet Archive, and that's another 2.5 petabytes. So across these, there's probably about 5 petabytes. It goes megabytes, and okay, test here. Megabytes, what's 1,000 megabytes?
Kilobyte.
Nope, 1,000 megabytes goes the other.
Gigabyte.
Gigabytes. 1,000 gigabytes is a terabyte. 1,000 terabytes is a petabyte. So this is about 5 petabytes. All of the words in the Library of Congress would be in a few inches in the bottom of one of those. The lights actually mean something. Every time a light blinks is somebody either uploading something or downloading something from the Internet Archive. There's, we get about 2-3 million visitors, users every day that are using our collections. It's about the 200th most popular website according to Alexa Internet. So it's popular. There people actually want old stuff, which is kind of, I find, really encouraging. Another interesting thing is it's out.
Let me just take like 5 seconds of this. Not creepy at all.
There is no air conditioning either. So we're motivated towards being cheap, but by the way, we're also green. So we don't have any air conditioning, which drops our power bills by about a factor of 2. Also, the co-location costs usually are very high, so we just converted these offices into this. And we've been doing this now for about 13 years. This using air-cooled, Mother Nature-cooled system. It's coming in at about 74 degrees Fahrenheit and going out the back at 95 degrees Fahrenheit, which we pump through the furnace, which we keep the gas turned off and use it to heat the building. So we're not only not using much energy for the servers, which we're really not, we're using the waste heat. So we're using the energy twice. So I think we may be the first data center that's over 100% efficient. But it's completely doable. And this is a major website, right? This is, so it's not a toy, but you can actually do things in very dense, low power if you take that as a major goal. A lot of commercial companies, they have more money than time, and so they kind of go with a fairly normal approach. So we try to basically apply cleverness to try to get us out of paying money. So we pay money to ourselves, I guess, would be another way to look at it. So doing them using UDP up in Linux boxes to put them back together, again, into programs that are chopped based on electronic program guides into the sort of the different segments of a television, and then we process those into smaller forms, and also in the United States we've got closed captions which we can take out to make it searchable. Other world things, it's really difficult to navigate through these materials, but at least they're safe. So another thing we really need is text in a bunch of different languages to be able to help people move through these collections more easily, because we don't have the manpower really yet to be able to do that.
How do you avoid duplication with like Google Books and like what Google's doing?
Google Books. So Google and us,
We're here at the electronics flea market.
That's actually how I did it in San Diego.
And this is whisker porn.
Mm-hmm.
So it's 5.
Video, there's a YouTube channel there. They get kids to show on YouTube videos and get the reactions. But it's good. At least give them those apple shirts. It's good food, yeah. Oh yeah, they do have the company store, they call it.
Guess who that is? I'm taking a video, guys.
Oh.
You're a terrible person.
We're like,
this is like, yeah, this is one of those ones where somebody stands there with a camera and everybody thinks that it's a photo. What are you doing?
That's a real. That's a
I know,
real
just
Tindie.
you point.
Celebrity
Like, point.
in real life.
I'm not.
Oh, you never
Celebrity.
met in real life before?
No.
No, man, it's the first time.
Oh. Where you been?
Alvaro.
I've met them in real life. Oh, that's
Yeah, that's right.
okay.
I like it. Oh man, I can smell it from here. And the aftertaste is horrible.
I think the smell is worse than the taste.
It is. The smell is worse than the taste, but wait until you burp it up later.
I'm immune to this strange stuff, but she always makes me eat weird stuff.
Oh no!
Here, smell the bag.
Oh no, I can smell it from
Smell
here.
the bag.
I can smell it from here. Hey, Whisker. We went.
They didn't have very much at HSC.
Nope.
No.
I hate leaving empty-handed.
HSC Electronics. Famous. So you guys did the egg bot. That was really cool. That was very impressive.
And I can show you some of the things we played with it here. So the big thing we did this year, we do projects, right? Our new one this year is a wax resist tool for the egg bot.
Oh, nice.
So this is a little hot wax tip. It's got a, you'll appreciate the heating element once you see it.
It's just a giant resistor.
No, look, 3 pins, not 2.
It's a transistor.
It's a MOSFET.
Huh, and you just use it as a heating element.
You just leave it on or sort of mid?
It's actually the current regulating element of a little circuit there. There's a little 5-pin op amp there. It's a baby current regulator circuit with the transistor as a switching element, only there is not actually a resistor that's the load, because I'm actually using the MOSFET itself as the load, the internal resistance. Anyway, we can heat up wax with it, dispense it to the egg, dip it in the dye, and then wipe off the wax resist. And so this is, the 4,000-year-old traditional egg decorating technique, only now it's robotic. So that makes it cool.
That's cool. That's really cool.
Whoops.
That's really neat. What was it originally for? You
Oh, so you
think?
can actually, wow.
Yeah, it's actually spherical. There we go, back in, and boy, I'm on video twice.
What would the intended use be?
So a spherical roller bearing, so this has rollers, not balls, which means it's designed for heavy load.
Okay.
And this particular version with the 2 angled sets of rollers at separate angles is particularly good at handling very high axial load. So one application of this is you have a floating platform that is your oil drill rig, and you have a mile-long piece of steel hanging down that's going to be varying its angle. It has to be able to handle immense load, pressing down this way, still be able to turn freely, support enormous weight and handle variations with it. So there are applications where this is the only type of bearing they can use for it.
Wow.
This one cost $5.
That's awesome.
Wow.
What do you think it cost originally when they were made?
Oh, this is military.
The metal itself?
$1,000.
Wow. Whoa.
Yeah, the metal
The
itself.
commercial grade version of that one would probably sell for about $300 to $500 now.
That's craziness.
But it's basically has the red solder mask ended up all bubbly and funny and weird.
Oh, I thought that was intentional.
No, sadly not.
I thought it was like pretending to be electrons or something.
So
We're actually seen the new solder mask process that Lane is using.
No.
The latest results are amazing. I put it under my my inspection scope and compared it to other stuff. The silk screen, just the detail on it is just astounding.
So he actually has a vendor that knows what.
Very nice way to get around the problem of how do you source like physical structure stuff because it's all PCB and standoffs. It's just great.
Well, even better, that version of the Eggbot over there is also PCBs and standoffs.
This one here?
Yeah.
I got a good action shot with your arm.
Who do you use for these?
Various sources, usually China for this one.
Okay, and you can just specify your thickness to whatever with them, yeah.
Yeah, but the really cool thing about this is that because this is FR4, there's a copper layer that spans the entire side. So there's an invisible heat sink here. The motors run cool.
Nice.
Yeah, great idea.
To show the time. Brilliant. Negative space.
Oh,
It's flex?
Yes, it's layers of flex PCB, but it's built in, it's a circuit board, but it's built in a wafer process, not a circuit board process.
Crazy.
Because they needed higher tolerances than were available in circuit boards at the time. This is one of the, what's called high density signal interconnect boards from a CPU module of a high-end VAX supercomputer from the last days of the VAX.
Wow.
So this was, they would directly bond the dies of all these different chips onto these things. And then these things came out into breakout boards onto massive connectors on all four sides. And these little cubes, each with their integrated fan and cooling system and everything, would be together on racks of the mainframe.
And it's all multi-layer flex.
Oh yeah, it's absurdly high layer count, and I've learned a lot about the process of how they made these things, but it's a unique thing, and if you look under the microscope, the pitch of the wires in here is just absurd.
And you have a blog post on it?
Yeah. It's now at the
I'll have to look at it.
upper limit of what can be done in a PCB process,
real.
but at the time it wasn't even accessible.
I thought that was the cutest thing when we saw it on Hackaday.
What was this called?
What was it?
That. It's like a footstool.
Oh yeah.
You can go ahead and pick it up, just note that it's heavy.
It's really neat.
So, it's a VAX 9000 series high density signal carrier. So I have some microscope view kind of pictures.
Oh,
here.
awesome. Here's the. Okay,
So from a
yeah.
$1 million VAX.
Wow.
So we're making watercolor butt frames today in parts of the ostrich egg butt. I would so love to replace the ostrich egg butt by a giant chunk of metal, but I'm not sure there's enough volume to do that. Got our laser, router, vacuum former, sander, custom little machine for machining watercolor butt, winches to exactly the right diameter.
What do you use the vacuum form for?
Not much. That's the one tool we use the least.
Okay.
But we do make the packaging for our Digicomp 2 mechanical computer on it. So I didn't show you that one.
Mechanical computer.
Yeah. The sets of yellow bins over there are the inventory. I have piles of stuff, including empty boxes everywhere. These are my new egg butt frames, waiting for that last one part to arrive. And then we're building miracle. You need 100,000 LEDs, here they are.
Oh, look at this. Oh, there's the. Okay.
That's the big one. We brought this connector here a couple times. We also make a desktop.
Fun.
So we actually did sell one of these. If you go into the lobby of the computer science department at MIT, you can now play with the Digicomp 2 we built for them.
Oh wow.
Wonderful.
I can show you the desktop version as well. Oh yes, and then I'm going to offer you.
Oh yeah, they got the whole
Is this all
Photoshop.
wired underneath? Is that how the intelligence is done, or is it just different mechanical?
Strictly mechanical. There is no intelligence
Wow.
besides what you see.
Okay.
Okay, would anyone actually like an eggbot workpiece? Can you take this? Yep. So this is a wonderful mechanical linkage here. It's this cam in here. It's okay. Which is replaceable. Has two sides and then a vertical cam as well. And this encodes by XY and minus XY the same way that a record player does the two dimensions. And then this screw needs to be tightened. And then as these wiggle, it pushes the pen that way or that way.
And
That's Y,
the
minus
ridge
XY.
pushes the pen down to the paper.
Center, yeah.
Yeah, lifts pen up, pen down control as well.
That's like a little egg bot.
It is exactly like an eggbot, and we may get around to making a desktop version of this with minus the cam. That part's obsolete.
Yeah,
Right.
because you can do all that just in code now.
Can you find
Absolutely.
on eBay like extra cams for this type
I'm
of
sure you
machine?
can. This one is from a UC Berkeley chancellor named Bob
Oh,
something
yeah,
or other.
Bob Bergen.
Yeah, and we think that everyone who had one of these, or everyone who used one of these machines, had multiple cams. So this was the informal. Thanks
Yep.
for coming to our fundraiser last night.
yeah.
Bob signature.
And it'd be like a doctor.
Not the on your diploma signature. Bob,
Right.
But you know, you want that signature on your diploma to look like it was written with a fountain pen. So it has to be written with a fountain pen. So they have this thing that fits a fountain pen at just the right angle.
So that the ink flows.
That is so cool.
We actually ended up making the giant one for Maker Faire before I'd ever seen an original.
Your balls aren't rolling because the table's not level. You need to. Oh, but it finished anyway.
Yes.
Ha.
So that last ball came down this way, so it doesn't hit the
I
start
see,
lever and
yep.
it halts. We can simulate that. Put it back to where it was before that last ball, which goes down
That's
like
fine.
this. So it goes down this way and it misses the start lever.
That's so good.
Okay, so and
that
our
for
results.
12s?
Okay, 0 in the 64s, 0 in the 32s, 0 in the 16s, 8 plus 4
Yeah.
plus 0 plus 0.
Yeah, math works.
Love it.
So cool.
So you're all familiar with the 2's complement operation, what that means? It means invert every bit and add 1. And 2's complement is the binary representation of negative numbers. So I'll just sort of multiply off, complement on, auto, and then what this is going to do is it's going to invert every bit here, and then it's going to add 1, and that'll be negative 12 that's represented after we do that. So this right now is an adder. If you add a ball to the top, it adds 1 to this. What we need to do is invert it. But if all these switches were flipped to the other state, now it would be an inverter. So what the digicomp does, it has a 4-cycle sequence. The first step is to change this from an adder to an inverter. The second is to invert every bit. The third is to change it back from an inverter to an adder, and the fourth is to add a bit.
Yep.
And then it stops.
Oh, so it changes those. Ah, I see. Okay. And now that it's set to an
Now it's
inverter, it
inverting.
inverts everything. Then it's going to change it back
And then it halts.
after it adds 1.
Yes.
Here's the
Add
add
one.
one.
Carry, reject. Ta-da!
Yep. That's awesome.
Okay.
Negative 12.
Negative 12. Now, if we want to prove that that's negative 12, we need to add 12 to it. The fastest way to do that is to take, let's just do 1 times 12. That's too boring, isn't it? Let's do 6 times 2.
Okay.
4 plus 2 is 6. 2, 0, 0. Okay, and complement off. And I'm going to need more balls for this.
I just want to say today has gone much different than I thought it
See,
would.
aren't you glad we forced you to come along?
What were you planning to do today?
He was going to ride home after the flea
You were going to get some work done?
I do have, yeah.
This is way more inspiring than work. Did it take you a lot of iterations to get the design of this one working?
Yeah. Although, it's less than you might think.
Yeah.
Certain parts of it took a crap load of iteration, like the exact shape of this arm.
Okay.
We actually had a summer intern a couple years ago whose job it was to work on this, and all of the hard part of this is summed up in this. If you can get these 3 flip-flops to work,
To start, then the rest.
then everything else flows easily.
Okay.
And so, sort of spent a summer playing with those. Didn't really end up with a proper working model by the end of summer, but we did get the vacuum form repurposed with the intent to do the pressure form version here in house. But yeah, sorry. Non-level table. You can tell this table is high quality and level and all that, right? So yeah, there's a lower deck. When it goes down into one of these holes, it just goes straight down to here.
Okay, but then along the switch from inverted to, or from
So behind
an adder to the
behind each of the switches in that section, there's a flip flop.
Okay.
So to
on the underside. Okay.
And we're done.
Yep.
Okay, N0.
That's cool.
Yeah.
Cool.
Behind each of the
clear. Oh yeah, we haven't shown the clear.
We've done clear, but for clear you have to have some things.
So clear on, multiply off, manual pull.
So behind each of the accumulator flip-flops is a half flip-flop.
Okay.
So it either rolls off of it or it turns it to 0.
Okay.
All right, here are all the options. So I did it on 99 Designs. So if you want to see all of the possible Tindies.
Whoa!
Did you say I want a dog?
Yeah, I said I wanted a robot dog. So the design brief was mascot, Etsy for tech, homemade electronics. This is all the original stuff.
Wow.
And how long ago was this?
This was like April of 2012.
And how many responses did you get?
100.
Wow.
And so here's the ones it was narrowed down to. And then it basically was, which would you rather have as your, like, a sticker on your laptop?
Yeah, having extra colors too is hard.
That's
for
right.
stickers and stuff.
Awesome.
Every color costs.
There you go.
Yeah.
The history, the making of.
Are we still videotaping?
Gosh.
We post videos all the time, so don't forget to subscribe and follow us on Twitter at TYMKRS.
He didn't know the logo yet.
All right, we are here at Tindie HQ with Tindie CEO.
You just say
Emil.
Tindie founder. You don't have to say CEO part.
CEO,
I never
boss,
say CEO.
head, dude.
Janitor.
He's the head janitor.
Secretarial staff,
IT director.
So here,
consulate.
Consul general.
Your Eminence.
That's a bit pompous.